Hi everyone. In this video I am going to explain about a two-input NOR gate design using NMOS logic. So NMOS logic means in the previous video I have explained about a CMOS two-input NOR gate where CMOS consisting of a PMOS transistors and as well as NMOS transistors. But whereas in the NMOS structure all must be of N type. All must be of N type. There is no PMOS transistor. Okay, for that purpose we are using a depletion mode transistor, in pull up place, in pull up position. What do you mean by pull up position? Between VDD and output. Between VDD and output, we use a depletion mode NMOS transistor. The purpose of depletion mode NMOS transistor is depletion mode NMOS transistor acts as on circuit. Always it is an on circuit until we provide a negative gating input. Okay, so a depletion mode NMOS transistor looks like this, which is having a channel representation. In depletion mode, I told you already the difference between depletion mode and enhancement mode. In depletion mode, the channel is already established. There is no need for taking VGS. So that's why the gate is generally applied with VGG is equal to 0 volts. There is no use of gate voltage. Okay, there is no use of gate voltage. That's why this is generally connected back to the source. This means it is short circuited and there is no voltage provided. So simply VGS is equal to 0. Okay, so depletion mode simply acts as a resistor, a low resistor, on resistance. This on resistance we are using here in between VDD and output. What about the pull down network? Pull down network is generally consisting of enhancement mode, NMOS transistors, enhancement mode NMOS transistors. So this is nothing but pull down between output and ground. Okay, so enhancement mode realization is generally depends upon the type of the circuit we are using. Now consider two input NOR gate. So two input NOR gate. I told you we are using a depletion mode transistor and a two input NOR gate realization NMOS transistors for NOR realization A plus B. NOR is nothing but Y is equal to A plus B whole bar. For plus NMOS transistors, for plus realization they should be connected in parallel. Okay, this statement I have given in the previous video. So they should be connected in parallel. And between output and ground, VDD. Okay, there is no PMOS transistor, so don't forget the first one is NMOS depletion mode transistor with a channel. So this voltage is simply applied with 0 and it is connected back here. This is A input and this is B input. So this is the output. Okay, so NMOS depletion mode and NMOS enhancement mode. Okay, so one depletion mode transistor and two enhancement mode transistors. To realize Y is equal to A plus B bar. Okay, always the default structure gives you the complemented version. If you want to go for OR gate, then again you need to connect one inverter at the output to get the true form. Okay, this is two input NOR gate. Suppose consider a generalized structure, a generalized NOR structure with multiple inputs. That means Y is equal to, previously we have seen A plus B whole bar. This is nothing but two input NOR gate. Two input NOR gate which is made up of NMOS devices, purely NMOS devices. Now y is equal to, the thing is we are taking multiple inputs. Multiple inputs means a plus b plus and so on. We are having n number of inputs and so on, n number of inputs, whole bar, whole bar. Okay, so we are having multiple inputs, multiple inputs. How to realize the circuits? Here we have multiple inputs, multiple inputs. See how many number of inputs we have, that doesn't matter, but the thing is we have to use a depletion mode transistor always between output and VDD, and the realization of the NMOS transistors, a parallel set must be connected always in the pull down network for NOR realization. Okay, NMOS transistors, that may be 1, 2 or 3 and so on, 2 or more for NOR realization. NMOS transistors 2 or more must be connected between output and ground, in parallel connection, in parallel connection. Okay, let us see how the circuit looks like. So a depletion mode transistor, as I said, a depletion mode transistor here, a depletion mode transistor, this is connected here back, and now multiple inputs we have. Multiple inputs means more than one input. So here we have one transistor, here we have one transistor, here we have a set of transistors, group of transistors connected in parallel for which realization? NOR realization. Don't forget that for NOR realization only we connect them in parallel. Okay, and all these are in parallel means here. Okay, this is ground. Now we have here input A, here input A, input B, input C, and so on. We have n number of inputs. So here we have multiple inputs, multiple transistors equal to number of inputs. Number of inputs. How many number of inputs? That many. And always whatever may be the realization, always the output is taken from the center of these two transistors. Y is equal to A plus and so on, A plus, B plus and so on, N whole bar. That is nothing but NOR realization. This is nothing but NOR realization. As I said, okay, if you want to use a capacitor at the output, capacitor always, see, don't forget to take capacitor. Capacitor always should be considered whenever we are going for the analysis part. Okay, now suppose what happens regarding the power flow. See, as I said, this transistor NMOS depletion mode transistor, it is always in on state. It is always in on state. So there is a static current flow from VDD to output terminal, that is nothing but ID. This ID has been divided into the number of transistors, like ID1. ID is nothing but drain current. ID1, ID2, ID3 and so on. We are having n number of currents like this. Okay, so when all the transistors are in on state, then we are having the current flow ID is equal to, see, when all transistors are in on state, then the current ID is equal to IDS1 plus IDS2 plus and so on plus IDN. Okay, the number of transistors when all are in on state, this ID current has been divided into n number of currents. Okay, suppose if only transistor 1 is in on state, if only transistor 1 is on, then the entire current ID has been flowing through only ID1. Rest of the currents ID2 is equal to ID3 is equal to and so on plus IDN is equal to IDN is equal to simply 0 is equal to 0. So whichever transistor is in on state, that draws the current, and remaining transistors are in off state. Okay, and there is no switching action for the depletion mode transistor. Don't forget that. Okay, it is NMOS depletion mode. Because depletion mode transistor is always in on state, the static current flow is always available at this node. Depends on the on off conditions of the bottom transistors, the current flows. Okay, so in the next video I will explain the analysis part of this generalized structure, so that you can understand how the uh, capacitors are present and how different characteristics are going to be measured. That analysis is transient analysis. Okay, thank you.